The synthesis of nitrite complexes. All right.
Yeah. So it's a really quite an interesting lab in that this is the second lab that people are going to do in the wet lab this semester, and it's basically everybody is going to be making a different compound, and the way you're going to make it is well, I know there's a classic mathematics problem, basically, that says something along the lines. It's a limiting reagents problem, really, is what it is. So both in chemistry, it's a limiting reagent problem, but it's also a classic mathematics problem. So I'm building cars, right? Mm-hmm. And with those cars, I've got, let's say I've got 100 wheels. And I've got 50 seats. And I've got 50 doors. Okay. And so I'm going to build cars. But I have to decide, well, I can build a couple of different kind of cars. I could build four-wheeled cars with four wheels, plus 4 seats, plus 4 doors. And if I do that, this number of cars, this number of car parts will give me a certain number of cars. But maybe it's not a 4-door car. Maybe it's only a 2-door car. So maybe it still has 4 wheels. And yeah, it's still got 4 seats. But it only has 2 doors. And that might mean that I can make a different number of cars or something like that, right? So there are kind of classic limiting factor problems that people have encountered in mathematics and perhaps in other science classes. So what we're going to do is everybody in the course is going to take potassium nitrate, and they're going to combine it with 2 different compounds. One of them is going to be some metal attached to chlorine, attached to some water molecules, and they're going to take some other metal that's also attached to chlorine and it's attached to some water molecules, and they're going to combine those together. So it's like we have wheels, doors, and seats. Mm-hmm. And in this lab, everybody is going to have a different number of, well, I think everybody gets the same number of wheels, but they get a different number of doors and a different number of seats. And that forces the reaction, when they all combine together, to make a different ratio of K to M to this other M. And so, and based on the ratio of these 2 metals, this first metal and this other metal in this compound that has potassium, you're going to get different properties. And so there are some techniques that you're going to learn, but basically you're building a car with different numbers of parts. Everybody in the classroom has a different number of wheels, doors, or seats, different amount of potassium nitrate, different amount of this metal chloride, and a different amount of this metal chloride. And so it's going to force different compounds to form. And so that's basically what's going to happen. There are some interesting techniques in there. You're going to do some filtration. You're going to use an ice bath. You're going to use something called a rubber police, which is basically a little piece of rubber on the end of a glass rod that you use for scraping stuff out, right? And you're going to do something called vacuum aspiration, which basically means you force something to evaporate by having a machine suck on it really hard. Basically, what it boils down to. So, and you'll learn about what you'll see those techniques and be introduced to those techniques in the lab. But in generally speaking, this lab is about restricting the 2 metals in different quantities and seeing what kind of car you make as a result. That's the synthesis of a nitrite compound. What else should I say about that, Kevin?
I think that is essentially it. There's a lot of good chemistry involved, and whether or not at whatever point you're doing this lab, whether or not you understand all the topics, there's just classic chemistry lab fun experiences where you just make solutions with different colors. It's kind of what you imagine as a child, you know, you make one solution with one color and then another group does, even though you all have the same parts or almost the same identical parts, maybe like the doors and the seats are different colors or they're arranged in a different way. And so you get to see kind of experimentally, or you witness it yourself and not just through text and textbooks, because that can be very overwhelming.
Yeah.
Just some cool chemistry techniques like Dr. Hunter said.
Yeah, if you're one of the first groups that's doing this experiment, there's going to be a lot that you can't figure out what's going on. If you're one of the last groups, it's going to happen at a part of the course where, hey, there's a lot going on that you should be able to understand and relate back to what we've done in my part of the class. Don't panic if you don't understand it all. We're going to figure it out by the end of the semester, but just the way that things are cycling through, it's not all going to be known by you at all times.
Yeah, exactly.
Yeah.
I think that's everything. I think the math is kind of explained in the lab, so I think we covered what we should cover in this.
Your instructors are going to help you through this, right? And
we are currently not at the lab, so we can't show you any of this.
We're not in the lab, exactly. Yeah. Maybe we will be. Maybe we'll be able to update this one by the time this experiment actually gets closer to starting. But equally, I don't want to show everything. Right. The whole point is that the students have to do the stuff and have to learn the stuff. Right. If you and I show it on camera, then we can't do the learning for you. You got to do the learning for yourself.
Yeah.
Cool. Alrighty. Thanks, Kevin. Talk to you next time.
Yep. Talk to you next time, Dr. Hunter.